So let's talk about another one of our compound interest formulas, and this one is called continuous compounding interest. And the difference between having a bank account that is continuously compounded and one that just compounds n times per year is that in this case, continuous compounding, it's kind of like saying, let's let n increase towards infinity. What would happen? Well, in other words, if we let that number of compoundings get larger and larger per year, what we would see is that we were in fact using the formula, remember our limit, as n approached infinity of 1 plus 1 over n to the nth power, and we said that that value was equal to e. So if you remember that formula, then you can see that what happens is that our continuously compounding amount becomes p, the principal, times the base e to the r times t power. Kind of interesting. All right, let's see what that means for us. Let's say we invest our $1,200, only this time our account compounds continuously at that rate of 8%. What will the balance be at the end of 5 years? Well, using this formula, that says that our account balance should be our principal, $1,200, times the base e raised to the 0.08, and we're going to multiply that by 5. All right. That's like saying 1,200 times the base e raised to the 0.4, right, 0.40 in this case, right? And so if we were to get our calculator out and work this one through, I would work it out this way. I would get my e to the 0.40 here. Let me get my marker going here, 0, right? So e to the 0.4, so 0.4 e multiplied by that 1,200 amount. This time I get $1,000, $790.19. Now, if you want to compare that, in our last example, we got $1,783. So we do $7, well, $17 better than we did when we were accumulating quarterly. Is this always the case? Will we increase? Well, I think this is about the largest amount of money that we could earn by earning interest by using what's called continuously compounding interest. So that's how the formula works.